So today's objective, we are going to be writing equations of parallel and perpendicular lines. We are going to be talking about parallel, which means two or more lines that never intersect, and perpendicular, which are lines that intersect to create a 90-degree angle. We also call this a right angle, and we'll get into that more in geometry. So parallel can often be represented as mathematical shorthand by two tall kind of L's, and that represents parallel. So if you see this symbol, that means we're talking about parallel. And perpendicular can be represented by this symbol, which looks like an upside down T, to kind of represent the types of lines. And we see this in textbooks, on worksheets, you'll see it in the video. So just know that that means parallel and perpendicular. And another thing to note is that when we're talking about perpendicular lines, if they want to let you know that lines are perpendicular, they mark that with a little rectangle or a square in the corner so that we know that this and this line are creating a 90-degree angle. And if they want us to know that we have two parallel lines, we have marks that we put, they look like little arrows. We call those tick marks. That lets us know that those two lines are parallel and will never cross. So this is just some mathematical shorthand related to the topic. So, what do parallel and perpendicular slopes look like? If we're going to be writing equations of parallel and perpendicular lines, we need to be able to recognize their slopes. So parallel lines have the exact same slope, and perpendicular slopes are opposite reciprocals. Opposite reciprocals. So an example of parallel slopes or exact same slopes would be if I had my rise over run for one line was 1/4, and my rise over run for the other line is 1/4. They are exactly the same. They're both positive. They both have a 1 in the numerator and a 4 in the denominator. So that is an example of two parallel slopes. Now, opposite reciprocal, opposite just means different signs. So if one is positive, the other has to be negative. And reciprocal is when the numerator and denominator flip. And we'll write flip in quotes because they're not really flipping, but they're going to be in the reverse order. So an example of opposite reciprocal slopes or perpendicular slopes would be if I had one line with a slope of 2/3 and another line with a slope of -3/2. Right? And here we can see that the numerator and the denominator are flipped. So in the first slope, my 2 is on top, and in the second slope, my 2 is on bottom in the denominator. In the first slope, my 3 is in the denominator, and the second slope is in the numerator. So they really need to have the flip in the numerator and the denominator, and then our opposite, meaning that the first one was positive, the second one was negative. So these are examples of perpendicular slopes. So a common error that we see with our slopes is that we don't simplify completely before deciding if it's parallel, perpendicular, or neither. So often we're given two slopes and we're asked, are these lines parallel, perpendicular, or neither? And we rush and we jump to conclusions. So we must make sure that we are simplifying completely so that we're not making mistakes. So for example, they're giving us line 1 has a slope of -4/7. Line 2 has a slope of -7/-4. And we think, is it parallel? Are these exactly the same? No, so I know it's not parallel. Is it perpendicular? Well, one is negative and the other is negative. Even though the numerator and denominator are flipped, since they're both negative, it can't be perpendicular. So I'm going to say neither, which is actually the wrong answer. We forgot to simplify. If we simplify, line 1's slope stays negative 4 over 7. But what happens when we have a negative over a negative? This actually converts to a positive. So if we simplify, now we have a positive 7 over 4. We can see that line 1 was negative, line 2 is positive, and we do have reciprocals. 4 was in the numerator, and now it's in the denominator. 7 was in the denominator, now it's in the numerator. This is an opposite reciprocal, so actually these slopes are perpendicular. So that's just a common mistake that we see when we're rushing and we're not simplifying the slopes. So make sure you're double checking and simplifying every time we're thinking about parallel, perpendicular, or neither. So now we're going to get into the meat of the objective, to write the equation of a line. What is the formula that we have to know in order to write an equation of a line? Well, hopefully by now we know that it is y equals mx plus b. Remember that m is your slope and b is your y-intercept, or where it crosses the y-axis. So using y equals mx plus b, if we're given information, such as we have in example 1, where a line is passing through the point 5, 4 with a slope of negative 3. They want us to write the equation. Well, we substitute everything that we have into our slope-intercept form to find our missing information. Remember that every slope-intercept form equation should be written so that we have a number in place of our m and a number in place of our b. So if we don't, we need to do some work to find it. So I know that my slope is negative 3, so I can substitute negative 3 in for that. I know that I have a y and an x value in my points because every point is an x and a y. So I can substitute my y with a 4 and my x with a 5. And I am not told anything about my y-intercept, so I just have to leave that as plus b. And I know that I need to have numbers for m and b, and I don't have a number for b, so I need to solve. Luckily, I have all of my other information, so I can solve. So I simplify by multiplying. 4 is equal to negative 15 plus b. And in order to isolate my variable b, I need to undo the operation. So undoing an addition of negative 15, I want to add 15 to both sides, and add 15 to both sides. That eliminates my negative 15. 4 plus 15 is 19, and that is my b. So I can use this to substitute back into my slope-intercept form. So an equation with a slope of negative 3 that passes through the point 5, 4 is going to be y equals negative 3x as long as the y-intercept is at 19. Right? So hopefully this is a review. Hopefully we saw this last year with our freshman teachers. So now we're going to be building on this concept with the idea of parallel and perpendicular. So example number 2. Write the equation of a line that passes through this point, negative 2, 3, and is perpendicular to the line y equals negative 4x plus 1. So in the last example, we had a point, which was an x and a y, and we had a slope. Here, we're given a point, which is an x and a y, and we're given an equation, right? Why would they give us an equation? Well, because we need a slope. But more specifically, we need a perpendicular slope. So we need to make sure that we're not only identifying the slope, but that we're answering the question and finding the perpendicular slope. So I want it to pass through negative 2, 3, and my slope in the equation that they're giving me is negative 4. So my perpendicular slope, which is what I want to use, is going to be the opposite, so it's going to be positive, reciprocal. So this is like negative 4 over 1, so my slope is going to be 1/4. This is the slope that I want to use when I'm writing my equation. Right? So now I have an x and a y and a slope, I'm going to do the exact same thing I did in example 1. I substitute everything in to my slope-intercept form. I know that my y is 3. My slope is the perpendicular slope, which is 1/4. My x is -2. And again, I don't have my information for b, so I need to solve and do a little work for that. So I simplify. 1/4 times -2 is going to simplify to a -1/2 plus b. I can get rid of the 1/2 by adding 1/2 to both sides. This eliminates and isolates my variable b. And 3 plus 1/2, we can just leave it as a decimal. You can leave it as a fraction if you prefer. But there is my y-intercept. And now again, I can substitute that back in because I know my perpendicular slope and the y-intercept that I need to get using that perpendicular slope. So my final answer should be y equals 1/4 x plus 3.5. And that is the equation of a line perpendicular to this line. And again, we should be able to see its perpendicular very clearly because here was this slope. And here's our slope, and they are opposite reciprocals. So we need to use that opposite reciprocal in order to get the correct equation and the correct y-intercept or b value. Moving on, getting more and more difficult. In example 3, we have new information. We want to write the equation of a line that is parallel to the line that passes through 2 points. So before we had a point and slope. Now we're just given 2 points. So what can we do to find the slope? Well, this is going back to the most basic equation of slope. I know that slope can be found when we have 2 ordered pairs using y2 minus y1 over x2 minus x1. And here I have my x's and y's. So I can substitute this information in. I have 10 minus -2 over 2 minus 5. Here I need to make sure that when I'm subtracting a negative, it's actually like addition. So 10 plus 2 is 12. 2 minus 5 is -3. And 12 over -3 is -4. So my slope of the line passing through these 2 points is -4. And if I want to use the parallel slope, I want to use the exact same slope, so I don't need to change anything. So now I go back to the same type of problem like I had in example 1, like I had in example 2. I had a point and I had a slope. Here I have 2 points. Does it matter which point I use? No, not at all. I can pick either point. So if you want to pick the one with lower numbers, pick that. If you want to pick the point with positive numbers, pick that. I am personally going to pick the positive numbers. So I'm going to use 210 with a slope of -4. Now we have almost the exact same thing as problem 1, where I substitute everything into my slope-intercept form. My y is 10, my m is -4, my x is 2, and I'm looking for my y-intercept, or my b. When I simplify, I get 10 equals -8 plus b. To isolate my b, I need to undo my -8 by adding 8 to both sides, which gives me 18 is equal to b. So the equation of the line y equals -4x plus 18 is the equation of this line. Right? They wanted me to write an equation of a line that is parallel to this line. So I found the line that they were talking about. Now I need to find an equation of a line that's parallel to that. There's many answers. Any equation that you write that has a slope of -4 is going to be parallel. So all you have to do is change where it crosses the line. So this one we're saying is crossing at -18 with a slope of -4. I can pick any line that has a slope of -4 and just change where it crosses. So one example would be negative 4x plus 10. Perfect. It has a slope that is parallel to the original 2 points, but it has a different y-intercept, which means it's crossing in a different place. You can pick any number except for 18, because if you pick 18, then you're just giving the equation of a line that they were already describing. All right, so hopefully this is some review. Make sure you come prepared with any questions, know what parallel and perpendicular slopes look like, and know how to find missing information in equations.